This is the Amp Hour Podcast. Released April 12th, 2020. Episode 488, sponsored by Roden Schwartz. Sowing Discord.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Campbell of Contextual Electronics.
In lockdown. Yet again.
Yeah.
It's
a little disheartening. Yeah.
But they haven't locked down my dumpster. I'm still dumpster diving.
I saw that, yeah.
Yeah,
Are you sanitizing everything as you pull it out, or?
Well, once I get back, get out the precious alcohol, get out the precious IPA, which was like what, $15 for like 5 liters like 2 months ago. Now it's like, oh, my precious. It's like because I got a 3D printer, one of these new LCD type ones,
Oh yeah, like the SLA type. Yep.
And the SLA, which uses an LCD to expose each layer. And apparently you've got to like clean these things with IPA or something. I don't know. I haven't actually tried it yet. And the company sent it to me, and it's like they didn't send me any of the liquid, never one like the UV curable liquid, the goop stuff. And everyone was laughing at me in the comments saying, sucked in because the goop costs more than the 3D printer is. And then
it's a razor blade model.
Right, yeah. It's the inkjet, right? They give you a free inkjet printer, and
Right. Pretty smart, actually.
And then on top of that, you got the IPA. Apparently, I don't know why, but everyone's telling me you've got to use huge amounts of IPA to clean these prints up or something. Have you ever used one of these SLA printers? I've
never actually done the actual post-process. I mean, I've, handled the parts before, and I've had someone else do it, but no, I've never done it myself.
Right.
That's like, Forum Labs is like one of those as well, right? That's like of
course. That was one of the first sort of, affordable ones.
Community ones, right? Yeah, cool. So what is the IPA for? Is it like?
I don't know. I haven't actually used it yet. It's for cleaning. Apparently, you got to clean the parts somehow and wash it all off, and you use huge volumes of now, liquid gold,
right?
which is IPA. Yeah,
liquid gold that just disappears if you leave it on your desk.
Liquid gold, Texas tea. It's the new Beverly Hillbillies. Sorry, you're that's way beyond your.
I used to watch it.
Age. Yeah, really? You used to watch Beverly Hillbillies?
It wasn't like new episodes,
no,
but
right.
I used to watch it.
Okay, reruns.
Yeah.
Oh god. Anyway.
Yeah.
So yes, I mean, still dumpster diving stuff. Maybe like a lot of companies will go out of business. Who knows? And I'll have to.
So 2 weeks ago we talked, and 2 weeks ago feels like 3 years ago. So what did we talk about 3 years ago? What did we talk about 2 weeks ago?
You know me, I can't remember.
I guess I'll pull up the show notes. We talked about medical kits. So yeah, we talked about, ventilators and similar things like that.
Yeah, there's been a lot of, I keep getting daily emails about new ventilator projects. There's just so many of them.
It's great. It's great people are working on it.
Yeah.
Because you made videos about the Medtronic files as well.
Yeah, had I made the second one since then?
I don't think so.
Right, okay, yeah.
Yeah.
It's good working on these products, but unfortunately, it's like such a complicated and dangerous thing. Like people are going, oh yeah, let's just cobble something together to save somebody's life. Unfortunately, it's not that easy.
Yeah. So Seth from the KiCad project is working, and other people from the KiCad project as well are working on translating the files to KiCad, and then also I think there's some other efforts to get the firmware.
The Medtronic ones, really?
Yeah. And it's got like an ST10 in there. I forget what the other things. There's another processor in there as well. But it's medical electronics. Like so like one of the first things. So there's a video stream you can watch where he's actually doing it too, and
right.
One of the first things he says is like, there's like a RAM on there. I think a DRAM maybe. I don't know. Maybe it was like NOR flash or something. There was some memory component on board where it was like you can't get it anymore. It was like from 2006 because of when the thing was designed. And then they had, they have contracts in place to buy these parts, but it's just like some of them just aren't in the marketplace anymore. And so at that point, you just have to replace it. So
It's a very old design.
yeah,
It's like 12 years old plus or something like that. It uses
right.
some.
And you say 12 years, it doesn't sound that old, but in the if you have no one actually like maintaining it for 12 years, it's like, oh man, you think about the obsolete components, like
Yeah, of
just the
course. Yeah,
number of notices you'd get.
it's
It's pretty
huge.
extreme. So
Now, it'd be remiss of me, sorry for harping on for those who have already seen my videos, but I'm gonna have to say this, in that just because the KiCad guys are converting this over to KiCad does not make it open source. So
well, yeah,
I don't know if you've watched my video or not. Please, for those who
I have not.
think that okay, the takeaway is that the license that comes with that Medtronics files, they are not free and open. The license is crippling. Okay.
I thought, yeah, it was like an exploding license. Like once this is over, it's like, no, never mind. You can't do this anymore.
You can't do this anymore. So they've put fantastic work, putting all that work in and converting them to KiCad, but that does not give other people then. It doesn't magically make them open source because you converted them to KiCad. Okay, it doesn't negate the license. So anyone who wants
Right.
to then take those KiCad files and think, oh, these are free, I can make ventilators for the rest of my life. No. Medtronics can come and sue your ass. So just be aware of that.
Yeah.
Watch my video and get your lawyer to read the license seriously. Like, because it's a trap. It's a trap. So, yeah, like, no, it is a potential huge legal trap, and you have to be aware of that. And you can really come a gutser. You could spend years of your life working on the world's best open source ventilator, but if you used material that came from this or this Medtronics design or some other design that you thought was open source, but it's not, then yeah.
Yeah, how does that? I don't think that maybe you've talked to your brother-in-law about this, but like how does that work with like prior art though too? Like, so it's like out there, right? It's released to the public, and then so if you don't copy it exactly, but you're like, oh, it's like inspired by this thing, and then you're using like the concepts there.
By well,
yeah. It sounds. I'm sure it's dicey no matter what, but
it is dicey no matter what. Only a judge can make that decision, right?
Right.
In a court of law. So it's not like.
Isn't that how the best things start, Dave?
Right. Anyway, I'm just saying, be careful. That's all.
Yeah.
Yeah. I don't want people to get caught out by this. That's my fear.
Yeah.
So anyway, anyhow. Yeah, tons of projects. And I showed this huge list of these, and it wasn't even a complete list. I don't even think half of them were on there. A complete list of all these open source ventilator projects and their current status. Somebody's maintaining this spreadsheet, which is absolutely awesome, which has tries to have every project, its status in like 5 different categories or something, like how open it is, what their current, is it, does it meet these requirements in this, and all sorts of stuff.
Does it have PEEP, and does it have like all of these acronyms that I'm like, I had never heard of before, and it's like, but they're like very, very critical to ventilator design and stuff like that. Now it's just like part of the nomenclature. It's like, oh, okay.
It's funny how everyone becomes an instant expert on ventilators. It's like, oh yeah, okay.
Yeah. I'm not one of them. Sure. I know that.
Yeah, exactly.
That. Yeah.
Anyway. Inductors. Can we talk about inductors?
Sure. Where's inductors? Did you put this on here?
No.
Oh.
But it comes from my teardown video that I just released this morning. Okay. Sorry, my repair video that I just released this morning. I was looking for an inductor, right? Because one of their, spoiler alert, an inductor blew in this laptop that I was repairing. And so like a big surface mount, a big 1820 jobby or something.
Like a DC-DC kind of thing that you're doing, something like that?
No. It was just the input choke. It was just the input choke coming from the power connector, right? So you didn't really need to replace it, right? You could have just put a wire link in there and it would have been fine, right? It doesn't matter. It's just like an EMC kind of thing, right? And so it blew and I needed a replacement. And I've got these inductor kits. I've got 3 surface mount inductor kits. Do you think I could bloody well find one that fitted? In 3, I've got like 80 different little tubes of
It was a
all these
footprint problem, not like a value problem or anything like that.
Well, it was both, pretty
Oh,
much.
okay.
It was not only like I found like in the end I just got one to fit, but the three little tubs that I thought would have been the right size and potentially the right
Uh-huh.
value, they were empty. It was like
Uh-huh, of
I
course.
had
Yeah, that's how it
depleted
always
them because
goes.
there's like
Yeah.
five, there's like 5 or 10 inductors in each one, and clearly over the years I've used that particular 10 microhenry
That's right.
size one, and it's like
Those kind of kits are like they're like inverse charts of how popular the thing is, right? So the more
yeah,
popular it
right.
is, it's like a heat
Mm.
map, but like in reverse.
Yeah, I was doing this the other day. I was going to discharge a whole bunch of batteries, right? Because I'm doing my
Oh yeah.
alkaline battery discharge test, right? So I wanted to discharge them all at once, and I thought, oh yeah, I'll just use a 10 ohm resistor, and then silly me realized that of like it'd be too much power, right? So I can't use a quarter watt resistor, right? So I've got big
Oh
stocks of
yeah.
quarter watt resistors, right? I've got every value E96 and everything else, but but I don't have A, big numbers of them, and B, not 1 watt ones, right? Which is what I technically needed. So I needed
Right.
to make up multiple ones. And it's like, well, I don't have that many freaking, I needed like 100 resistors or something. It's like, I don't have that in my general mixed value stock. I might have a box of like 1K. I might have like 3,000 1K resistors in a box somewhere, right?
Yeah.
Like, how they come in those bandolier boxes.
Yeah, exactly.
The,
Yep,
the,
yep.
the axial ones, the bandoliers.
You're right. It's the boxes that eventually you're going to throw away, and you're going to be like, when am I ever going to need this? And then the next day you're going to
3,000 1K resistors, but I needed like 100 like 10 ohm resistors or something, or 20 ohm.
Oh, I was going to say, you were trying to get to like so you were trying to have like 10 ohms for each battery. Is that the idea?
Yeah, for each battery to discharge each one individually with a 10. So in the end, no, I didn't have the number of resistors available and number and type of resistors available. So I had to discharge them one by one on my load.
Oh, really? Yeah.
Electronic load, and took me like 4 days or something to 4 or 5 days to discharge them all. Anyway,
Yeah.
so these parts kits. I mean, how many different type parts kits have you got? I mean, you should have a resistor kit at a minimum,
Of course.
right? Do you have a capacitor kit?
I have some booklets of capacitors, not like an extensive set. I find that like the I haven't updated my books in a while.
When you say booklet, you mean like a little folder with like little individual strips of each one that you can buy those on eBay for.
Yeah.
Yep.
Yeah, so not like a full kit. And nothing like not power stuff. Like inductors, nothing, no power inductors, stuff like that. I have like one like an RF, I think it's branded as like an IoT kind of thing. So it's like, low value like capacitors and inductors for doing like for tuning RF stuff.
Yep.
It's been lightly used. But it is useful for that kind of thing too, where it's, like you don't want to go and like order from an online distributor. It's like, oh, I need like a 0.7 picofarad capacitor or 1.3 picofarad, like when you're like doing tuning stuff. So it's nice for that kind of thing. But that's pretty much all I have, I think. I think I used to have
pretty much all you have.
Yeah, I think I used to have some like potentiometers too, maybe, or something.
Yeah, I've got pots. I've got Zenas, for example. I bought a mixed Zena kit, so I've got every value of Zena. But
how much have you used that though?
I've used it in a couple of videos. I've used it in a couple of videos.
Okay.
Yeah, I've used Zenas. I haven't used them. I don't think I've used them for projects. I've used them for videos. So but I'm doing more videos and projects these days, so that's not surprising.
I think it's one of those things where it's like when you really need it, it's like like it's one of those very, very rarely used things. But then when you need it, you like need it, And
how far do you go stocking? Having your own stock,
right? Well, and I'm space limited too, right? Well, you're dealing with moving, right? So like,
no, I'm moving into a half size space, yeah.
Well, and even if you had the room, like, you got to cart it from one place to the next, and then you got to keep it maintained. And I don't know, like I think some people are working on projects where it's, they have the drawers and drawers of 74 series logic, and it's just like always used, and not just Ben Eater who's doing 74 series logic stuff.
We used to have that at work. We had the metal cabinets with the pull-out drawers, like this was like, 20, 25 years ago.
Circular tins of parts in there kind of thing, or?
Oh, no, full tubes. So we would buy but we would have a lab guy, right? We would have a lab tech whose job was to maintain the lab, right? And of course, if he'd periodically check the drawers, or you'd tell him like, oh, sorry, I just used the last 7400.
Yeah.
So we'd go out and
Yep.
buy another tube of 74HC00s and stock up the drawers, these huge big flat pull-out drawers, and you had tubes of almost every 74 series chip available.
Yeah.
It was fantastic. It's like our own mini DigiKey.
Right. That is quite a infrastructure investment.
It's pretty extreme. It's yeah.
We had that at Keithley. We had the localized part numbers. They have like internal part numbers.
Yeah, of course.
And so they kept those in like a drawer. That's the little metal tins I was talking about. So that was just like, it was drawers, but then like within the drawers there were like metal tins with like the part names on them and stuff like that.
Interesting.
And,
Okay.
yeah.
Yep.
It's tough. It's a tough. Who's it? I was talking to Alvaro from Unnamed Reverse Engineering podcast, and he has a friggin' fantastic system. I was telling him he has to make a video about it. He keeps all of his stuff in Partsbox, so I think we've maybe mentioned on the show before. So Jan runs Partsbox, partsbox.io. So Partsbox is like a self management system for parts. So basically, if you say you kept buying, you find yourself, I'm always buying 0.1 microfarad capacitors because I don't know how many I have in a project kind of thing. Well, you can actually like generate locations. It's basically a maintenance system for your own stock.
So it'll give you like a location of where it is in your stockpile. It's, row F,
Yes.
three down row F or something like that. So you can have a huge wall of parts and things like that. Or we also, at a company I used to work at, we used to have these, have you had those rotatable storage systems, like these motorized storage systems where they'd have all
like
these
a
bins,
carousel.
like a big carousel, and they're gigantic. They're like the size of a room, and these big, like huge carousels will go over, and once again you type it into the system and it'll rotate this whole big cabinet thing, and out pops your
so they had those at M Hub because M Hub used to be a manufacturing facility. So it was used for storage of like full reels and stuff like. It wasn't like temperature controlled, but it was used for storage of reels and stuff like that. And you can get vertical storage really. That's why it's really good. Right? Instead of having like rows of shelves, you have vertical rows effectively. And it's super fun. It's on the tour, right? But it's actually pretty useful for storing a lot of crap. Without taking up too much room.
Yeah. But I've got so much old shit though. I've still got parts. I've done a video on this. I still got parts dating back from the 1970s when I was a kid.
Yeah. Well, and you almost bought that collection of parts, didn't you? I remember you did a video.
I got some of it, and then I got a friend of mine who actually got it, who actually paid $400 for the whole lot, and he went there and took it all home, and then he rented his storage unit was filled with 80 document shipping, those cardboard document shipping.
Oh yeah, like legal boxes, yeah. The document boxes.
Yeah, he had like 80 or 100 of those stacked all through his storage unit. And like 6 months later, he was begging me to take them away for free. It was like, no, dude. Sorry.
No. Yeah, I mean, this is what every hackerspace deals with too, right? They get like donated parts and it's just like, they just sit there, like.
Yeah.
It's tough. I think you need to have a very certain mindset, and it's always good to have like certain parts around, like, like having like some LM7805 kind of things or something, like something like that, where it's just like, it's in every project,
Yeah, of course. I was actually going to sell a kit for this. David too, he did some work on this, actually compiling like the most often used Jelly Bean parts, because I still sell those micro sleeves, which is the sleeves that go into binders, right? You can still buy it on my store. I've still got heaps of them. And so I was actually going to sell like those actually pre-populated with all of the common parts. But I'm not talking I'm talking active parts. I'm talking, chips and transistors and things like that. So all of your Jelly Bean regulators, all your Jelly Bean op amps, all your Jelly Bean this and that.
And what happened?
Oh, it's a lot of work kind of. We did get a list, and it's like,
it's expensive, right? So if you had, this is actually the idea behind. So we've talked about this like 2 or 3 shows ago when it was you and I. We did. We talked about the open parts list, right? We were talking about it in the context of the Shenzhen parts list that has somehow been kind of a different idea. But the open parts list, it's like 300 parts, and it was this idea of like these really, really often used parts. Same kind of thing, right? The problem is if you go and buy, if you include the passives and the actives, and then say you have 10 of each, it gets pretty expensive, like it's not cheap.
Of course, no, it's $1,000 to stock up all your stuff. Probably, I don't know. It's like if you have 100 different parts and you buy $10 worth of each.
Well, it's still like the same problem is like, okay, so now you have, you got 1K, 10K, 100K resistors and maybe some 2.2s, and like you have some R6 values, but now what are you gonna do when you need an R96 value? And it's just like, oh, okay.
Yep.
Yeah. you still need the other supplemental stuff. So
yeah,
I don't know.
I think I might ultimately break it down into a more manageable thing. Like I'll just do one with voltage regulators. I'll just do one with op amps. And it'll get, and the actual kit will give you 10 different types of op amps. Something like that, right? Rather than, here's the be-all, end-all beginner kit. Just buy this and you're stocked for life.
Right.
Kind of thing. Yeah.
Yeah, no, it's a good idea, I think. I mean, like, you could do that kind of thing. Real quick, back to Parts Box, just because I want to talk about Alvaro's setup real quick, because I'm going to send him this link after we record the show and force him to make a video about it. He not only does all this stuff for his personal lab, he wrote some Python script that allows him to barcode scan all of the DigiKey bags he has, ties it to a label printer, and then he makes labels for all of the things he does. Like, it sounds really cool. So
it sounds like a mental illness almost.
It sounds like he's really into it. But like
some people.
What you really want to do is you want to like borrow Alvaro's lab and be like, oh, I just needed like, here's my parts list. Can I just go search through your stuff?
Yeah.
So.
No, some people that's their hobby. They just love organizing their lab, and that's fine. There's nothing wrong with that. Everyone wishes they could do that, right? It's just a matter of time investment, really.
Right.
Sure, I could do that and make a fantastic video, but I've got to spend the next year actually doing that to get this one fantastic video of this fantastic barcoded labeled system.
Well, and it's like if you're going to use it too, right?
Oh yeah, of course. No.
Because it's not just the one-time thing; it's the maintenance. The maintenance is
the maintenance of it. You've got to keep it up.
Yeah.
Yep. I have a hard enough time that, right? I get, I find these random bags that I've taken out of my kits. Oh, they're still on the bench somewhere. I didn't put them back because I was too lazy.
Yep.
I'll just do that afterwards, and there is no afterwards.
Right.
You just never get back to it, and then you find all these kits, these bags missing out of your E12 resistor kit. Because boy. Anyway,
that's why you need to hire a lab manager who is just a real hard ass that you need to hire like a drill sergeant from the military. Private, why didn't you put that 0.1 microfarad capacitor back?
It's great when you have it and it works. That's why I loved the company I worked at once when we had that lab with every chip possible. It was just fantastic. You just go in there and you could almost guarantee that this op amp or this 74 or 4000 series CMOS chip would be there. It's great. But
it's awesome.
But these days, you got so many, there's so many different variations. It's just ridiculous.
Right.
And then you've got, do you want through hole? Do you want surface mount? What type of surface mount would you like, sir?
Yeah, exactly.
Which package, sir?
Right.
And it's like,
this one DC to DC converter variant has 6 different types of packages. So good luck.
No, I know. It's just, it's painful.
Yeah.
Boy. Anyway, so I couldn't find a suitable inductor. I've got 3 huge inductor kits that, I still couldn't find one to do the job. It's just, it's nuts. Because the problem is, of course, you can't, it was like high current. The problem is, I could have, I had the size inductor to put in there, but it was 2.3 amps, which is actually a lot. right? That's a lot of current for such a small
Yeah, yeah, yeah.
little surface mount package. And of course, when you go, I mentioned this in the video, when you go up in inductance, it's not like, oh yeah, I've got okay every value from one microhenry up to 100 microhenries, right? A couple hundred mics.
Hmm.
But you can't just whack in the 100 microhenries because the current drops. Basically, the current drops proportionally with the value. So the current drops with as you increase the inductance value. It has to because you need a smaller gauge wire. You've got to wind more of them on there to get your increased henries, and the current rating drops. So so the 1 microhenry, the one that I had, the 1 microhenry inductor in the same series, all in the same series, was rated at 1.8 amps, but the 100 microhenry one was rated for like 100 milliamps. So it's like,
At the same size, you're saying?
at
Like the same
exactly the
size?
same size. Yeah, that's
Yeah,
right.
exactly. Right, right. Yeah, unless you get like much, much bigger. Yeah.
Yeah. So anyway, I did squeeze one on. It was one of those jobs where like the soldering iron's not actually touching the pad because the pad's actually under the lead.
Oh, yeah, yeah.
It's one
Yep.
of those like you put the soldering iron on the lead and then that heats up the pad, kind of.
Yeah. Yep.
Yep, yep. The
Mm,
old oversized component stuffed on the small pads. Yeah,
yep.
done that countless
I've
times.
done that one. Yep.
Yeah. Which pad size do you use in the standard? Do you use the small, medium, or large in terms of if the stand like the recommended IPC standards for footprints, right? Say you've got a 1206.
Mm.
They come in 3 standard variants: small, medium, and large.
Dave, I'm going to be honest here. I don't know much about the IPC
You
standard.
don't.
I use,
Okay, there you go.
yeah. What do you use?
Whatever's available. Well, it depends.
Yeah.
If you're working on a high density design, you're forced to use the small pad, which
Yeah.
means your fillet size changes and everything, like your solder fillets on your
Hmm.
components change, and it's and then you can't use the pads as test points, or flying probe test points, for example.
Right. Right. You don't have any like overhang.
Yeah, because that's one of the advantages of the larger pad size, is that it extends out so far from the component that there's actually almost like a flat bit that your fly-in probe tester can come down, your little needle probes can come down on and actually probe that particular pad
Yeah.
with the component on it. So it doesn't have to try and probe the top of the component, and then the probe slides off and ruins your day. And so it's a trade-off there. But if you've got the room available, and normally I would use the normal size IPC footprint
Hmm.
one. But no, if you're working on a high density one, then you go for the small size. Rarely will I use the large one, unless I have some specific requirement. And then I'll do custom ones, of course. So
I think usually at that point, I'm like, if I'm really getting tight on space, I'll just size down unless I can't. Like that's
right, yeah, of course. So you would size down an individual resistor or capacitor pad.
sure. Yeah. Oh, no,
Hmm.
no, no. I mean, I would size down the actual resistor itself. That's what I mean. So if it was like a 1206, unless I had power requirements, I'd be
Okay,
like,
so
oh,
you'll
well,
go
that's an
from an
0603 now.
0805 to an 0603.
Yeah.
Yeah,
Exactly. Yeah. Yeah.
gotcha.
And I think that, I mean, that's usually like I don't know. I kind of like eyeball it at the beginning of the design too. And I'm like, well, this one's going to be pretty tight. This looks like an 0402 kind of design,
Yeah,
you know?
right. Oh, of
So
course. Yeah, you've got
surely
to.
there's probably like someone who's done like a spreadsheet or a calculator or something that's like, well, if you're going to have 200 parts in this board, yeah, you can't use 0603 because of the size of the board it is, like that kind of thing. But
Yeah, that's called your brain.
I mean, I'm sure that yes, I have that calculator as well. I'm saying there must be an actual. I'm sure someone's written like a script or a calculator that's done that kind of thing before.
Ah, I'd actually be surprised if anyone would bother because the requirements are so like infinite number of variations that I don't think any
Sure,
such
sure, sure.
calculator would actually be useful. I think you just have to rely on experience and
Yeah, maybe.
human judgment on that one. Yep, I don't think you can script that. Someone prove me wrong, please. By the next episode, we want somebody to have written a script that. comprehensively. Unfortunately, you don't know until the end, so it's not like at the end of the layout. It's not like you can just
Oh
like
yeah.
test it. Like you can't. So that's a hard algorithm to tweak, right?
Yes.
Because if
Right.
you have to do like a couple of days to spin a board to test your new algorithm each time, um,
Right.
like yeah, that's pretty painful. So that's why I suspect nobody's done that. I'd be very surprised if such a thing actually exists. So, although various packages have density things, you can get maps. You can get a density heat map.
Oh, interesting.
These things exist. Oh God, when was the last time I used a PCB density heat map? Oh wow, it's a long, long time ago in a galaxy far, far away. But yeah, all of your top end tools, your Altiums and all the rest of them, they all have heat maps available, and
Hmm.
you can see like the component density and the layout density and everything else where where things are getting tight and stuff like that.
Yeah.
So that exists. It's probably not
Hmm.
in KiCad yet.
Yeah. And so would that give you like an idea of like I guess one of the things that would like be really useful for me would be how many like supporting components are there? Because really that's when density starts to become a real problem, right? If it's like,
Yeah.
okay, if I have like controlled impedance traces that are supposed to be close to a connector, okay, then that like
Mm.
is like a space limiting thing. And then if that component is paired with another component that also has to be near that component, that connector, but both of them have a bunch of supporting components with them, it's like it becomes
Yeah.
this like bundly kind of thing, and that's when it really becomes a problem. Like I just did a layout a couple weeks ago that was like that, where it was like, it was like bundled around USB, but then there was also like, there was all these, so the USB had diodes, for ESD protection and like a bunch of, but like the
Mm.
ESD protection diodes had to be big for some reason, so it was just like all of these things kind of piled up on top of each other. So like one part of the design was really, really dense and another part was like really wide open, and it's just sometimes you can't spread them out as much as you want to, but that's not what the heat map is.
Oh, that's God. It's been 20 years since I've used a PCB heat map.
Oh, okay.
Like it's
So not a
like I
modern
think
thing,
it's
huh?
literally been that long. Like layout has changed. There is, I believe. Oh God, I'm stretching my. I believe there are separate heat maps you can get for component density. So if one component, as you said, one component is surrounded by like 10 other passive support components, for example, then that
Yeah,
will
yeah.
show up as like a red part of your heat map because there's a
Yeah,
high
okay.
density of components there rather than spread out. And the other one is a routing heat map, like
Yeah,
because you've got 20 traces all flowing through there all next to each other. There's no more room to put any more, so it'll
yep.
show up as super red on your heat map
You're right,
or
exactly.
whatever. So
Yeah, and sometimes
yeah.
like if you have like I would think another thing would be if you had like a QFN or something like that, and you got this big, beefy, like center ground pad in the middle that you can't route through. It's like, oh, okay, well that kind of like just blocks off this whole area that you might be counting on
Yeah,
otherwise.
exactly. Yep.
So, no vias there, no nothing.
Yep.
Oh, layout, isn't it
No,
fun?
no, it's tough business, and it's changed
Yeah.
over the year. Like layout techniques have vastly changed, from through hole to surface mount, and then various types of surface mount and various technologies of PCB layout and
Hmm.
things like that. It's just PCB manufacture, sorry,
Yeah.
and it's just it's nuts.
Mm.
Changes over the years. When I was a boy,
Yep. Yep.
yeah, sorry, had to get one in.
Yeah, of course.
Mm,
One per show.
anyway.
We're focused on advertisers that help educate listeners of the Amp Hour. Today we're going to hear from James Lewis, also known online as the Bald Engineer. Not only does he have a great educational YouTube channel about electronics called Add Ohms, he's also a product manager at Roden Schwartz, our sponsor for today's show. Here we're hearing him explain how to use oscilloscopes.
A rule for test equipment is that when you add a probe, you change the circuit. To see how that works, we're going to use the Arduino's onboard 16 MHz oscillator and watch how it changes by adding a scope probe.
James is covering all types of scopes, but is using the RTM 3004 in this video, a Roden Schwartz 4-channel, 10-bit oscilloscope with up to 1 GHz of analog bandwidth. There are other variants in that product line as well. James shows how the characteristics of oscilloscope probes can alter the measurement you're ultimately trying to make.
The Uno uses a ceramic resonator for its clock, which is this little IC. Stopping the scope, I want to save a copy of the waveform so that I can compare it later. Now, some scopes put a reference function inside of their math functions. On the RTM 3000, there is a dedicated reference menu. From here, we can copy source 1 into R1. Now if I run the scope again, the live waveform is the yellow trace, and the white waveform is the saved trace. I have a second probe connected to channel 3. However, I am not going to display channel 3 on the screen. Instead, I'm going to take the probe tip and probe the same point that I'm already probing. And then I'm going to say probe one more time. As the second probe comes in contact, notice how the signal changes. The probes are loading down the signal.
This is a bit hard to see in audio, but the sine wave that represents the 16 megahertz signal coming off the oscillator is a lower amplitude. This is because of the, quote, loading that James is discussing is actually the probe capacitance. Adding a second probe effectively doubles the capacitance the signal experiences, which reduces the signal amplitude at 16 megahertz. Check out more of James's videos to see other oscilloscopes and general electronics projects. And if you're interested in learning more about Roden Schwartz and some of the value instruments helping engineers every day, check out askanengineer.us. You can see other reviews from people like James or from Shahryar, who we heard from last time. That's askanengineer.us. And now we're back to the show.
All right, what else we got on today's Amp Hour?
Well, let me tell you what we got here, Dave. So this was in the last episode you and I recorded, and I cut it out of it. And there was this interchange that Dave and I had right at the end of the show where we thanked our patrons. And then Dave goes, "We don't really do much for the patrons, do we?" And I was like, "Oh, shit, no, we don't." And so I was like, well, we should start doing that. And so in the meantime, I've set some stuff up. So we now have a community Discord. So our patrons, you sign up, you get access to the Discord. I've sourced some questions for them. We also are able to leave voice messages there. So that's going to lead into how we do the call-in shows eventually.
Oh, I didn't know you could leave voice messages on Discord. Basically, I don't use Discord. I've dabbled, but I'm not a Discord person, So you can leave, people can leave like little audio snippets, can they?
That's right. Yeah, exactly. And so I have another thing
cool.
about that in a second too, because there's another Discord thing that came up. This is also, this kind of relates back to like, hey, I am hungry for human connection and COVID is not helping with this at all. So basically, Patreon is tied right into Discord. So like you sign up on Patreon, you automatically get access. So it's pretty cool. We also give discounts on merch. So if you want to get a t-shirt, all that kind of stuff, there's different discounts for different people. And of course, we are super appreciative we're looking for other reasons to come up with stuff to send to our patrons as well. So if you have other ideas, things that you think would be, like group chat with me and Dave or something like that, we'll figure it out. I was thinking maybe we'll try and get the guests to go and do like a Q&A on there or something too. So
sweet.
We're brainstorming, but there is a Discord and patrons get access. That's a new thing.
Excellent.
We also, so that I do hardware meetups.
Yes, you do. You keep yapping on about it.
Not anymore, because the world is shut down. So some of the other hardware meetups that are out there, we all got together and started talking about like what can we do. And so Scott Shawcroft, who's been on the show before, him and Eric Moyer run the Seattle one, and Scott set up another Discord, and now we have a global hardware happy hour, which is kind of weird because it's like you're not meeting at a restaurant or a bar, but it's a kind of place to do it.
So it's joined all of them around the world, has it?
That's right. Yeah. So there's different like rooms you can join in for Chicago or San Francisco or Seattle or Austin or all these different places where there are actual ones, but then there's also just generic. Anyone can join there. So if you want, you can join there as well. And they've done one hangout so far, but we're actually going to try. Chicago's going to do a hangout as well.
This is a Discord hangout or a Google hangout?
It's a Discord hangout. So this is what's interesting about it. So I was thinking like,
is this a video hangout?
It's not. It's audio only right now. We're gonna try different things out.
Does Discord do video? I don't know.
It does. You can do video like up to 10 people, but you have to you can't do it through the rooms. You have to do it set up chats, and it's not 100% there yet.
All right.
One of the things that I was thinking about is we didn't want to just do one big thing. Like one of the things I hate about virtual conferences and all these other, all these things, it's always one to many, right? So even right now, it's like you and I are talking to each other, but it's also broadcasting to many, many people. The thing is, if all of our listening audience was in a room together, it wouldn't work, right? It would be like one person talking, then another person talking, then another person. It's just like, so you have to basically shrink the size down. So what we're gonna do is we're gonna try and do like a bunch of small like tables, like at a meetup, and we'll see if that actually helps people to
Right.
connect with one another.
Yep.
So
Well, that's like if people don't know, when you go to these meetups, like usually, like once you have more than like 3 or 4 people like standing together, like talking, it becomes too many. Like it's not like you can have
right,
one person talking and 10 people listening.
right. Unless there's like a demo. Demo is a different thing. I think.
Unless demos are different, you would have to
Yeah.
specifically go, guys, look, shush, listen up. I'm going to do a demo for the next 10 minutes, and then everyone stands crowds around watching. You know,
Right,
kind of. It's got to be controlled. It can't
That's
be
right.
like a free for all. If you've got 10 people all standing in a circle and chatting, it doesn't work.
Right. Yep. So we're gonna try that and see how it goes. And we're all nerds too, and so like some people don't want to turn their video on, no problem. It's just a chat.
Yeah,
and
right.
If you need to share something, you send a link, and you're good to go.
So, do you have to chat? Can you just like sit there and type? Can you just be a keyboard warrior?
You could be a keyboard warrior any day of the week. Yeah, so it's always on. It's always there. You can always be there.
Right.
But we're gonna have like a actual time to get together next week. So next
Right.
Tuesday. So if you're listening to this on Tuesday, it may be too late. But it's so the show goes out Sunday night. It'll be 2 days later. So early birds get the worm. But there will be other meetups for other cities and stuff too. So
Cool.
yeah, good way to keep in touch with folks. We'll see. See how it goes.
Excellent.
I miss people, Dave. I'm glad you and I get to talk. I think I've seen a total of 2 people in the past week.
Right. I haven't seen it. Well, I get to see my DHL driver, my DHL.
Yeah, right. Well, it's like family members, and then
Yeah, it's yep. It's the wife and kids, the DHL guy, the FedEx guy turned up the other day, and the post office.
Yeah. Right, if you're like stopping over somewhere, right? Yeah.
Yep. That's my entire life. Yep. It's my entire human interaction.
Hey. Yep. 2020.
So, I don't mind it. Just leave me alone.
Yeah.
I'm a solitary nerd.
Right.
It's like self-isolation for a nerd is not a problem.
Right.
Really. It's like, leave me alone.
Yeah. I was making a joke with my friends the other day that like so we were like doing like a Zoom call with like some old buddies, and I was like, the only real excuse you have anymore is like I'm sick right now and I literally cannot make it to the call, or I have another call. Like those are the only 2 valid excuses anymore. So,
what? Yeah. You can't be busy working on a project?
I mean, well, no, and there's many other valid excuses like you're taking care of your kids, or you got other stuff going on. But like if it's like past bedtimes, and I was like, my buddies don't have any any excuses.
All right, can we talk about the myth of 3 capacitor values?
Yeah, what was this? I saw you post this.
Right, yeah, because I've done a video specifically on this. I've done several bypass capacitor videos, actually.
I haven't looked yet. Is this going to be about voltage dependence of capacitors, or is it something else?
No, it's from Eric Hogerton, who we've had Eric on the show, haven't we?
That's right. Yep.
Yes, we've had Eric, Larry Smith. Sorry, I don't know who Larry Smith is, and Steve Sandler. Sorry, I don't know who they are, but I know Eric Hogerton, of course. Anyway, it's this article in the Signal Integrity Journal.
It's on brand for Eric, yeah.
yeah, right. Okay. And basically, there's this myth that you should put 3 bypass capacitors in value, and they should be a decade apart. So you'll put a 10N, a 100N, and a 1 mic, right? All in parallel. And basically, they're saying that anytime you see that, it means that
didn't know what they're doing.
That the designer has no idea what they're doing. It's like, yeah. And because this comes from, and I cover this in my video, it comes from the response curve, the ESR impedance response curve of a capacitor, right? So it's like, if you can visualize, it's it's not a bell curve, but it's like a slope that goes down and it peaks. So at one particular frequency, the ESR of a capacitor is its absolute lowest, right? And then either side of that frequency, above or below, it goes
Right.
higher in impedance, right?
It's like the inverse of a resonance peak.
It's the
kind of thing.
inverse of
It's like
a
V.
resonance thing. It's an upside down resonance thing. Anyway, so the theory is that okay, you want, for a bypass capacitor, you want as lower ESR as possible over as wide a frequency range as possible. And if you've only got one capacitor, then you're obviously only going to get that lowest ESR at one particular frequency. So that's why, like, the rule of thumb for the last like 50 years has been you put multiple capacitors in parallel and then they each have their own different dips. And then when you combine, when you overlay those graphs, right, then you have like basically a lower ESR over a wider frequency range. You have multiple low
That's
ESR
the theory
dips.
you're saying. That's the initial thought.
And it works, right? It's a real, like, there is truth behind this, right? It is a real thing. But the devil's in the detail when you actually take into account real capacitors and their package size and their lead inductance, if they've got leads. But then even then you've got end cap inductance. You've got your pads, you've got your vias going to your ground plane, and it's just like there's an infinite number of variables involved in the effectiveness of a capacitor. And there's another school of thought that says that you should only have one bypass capacitor and should be as big as possible. It should be 10 microfarads, or it should be 100 microfarads, and it should be, that's it. Because there's a lot of people that say, and once again, there's theory that can back this up, evidence that can back this up, that it's only the bulk capacitance value that matters, right? So, but but it all depends on the intricacies of your design, the specific requirements of your design, et cetera, et cetera. So there is no one thing is better than the other, right? And what they're saying is that basically anyone who whacks these capacitors in has not done any modeling whatsoever. They just have no clue what they're doing. They haven't done any modeling. And, well, that's great in theory, but the flip side of that is, well, okay, you're working on your design, right? You're laying out your board. You've got 50 chips on there. Each one needs its own bypass capacitor. Are you going to go and seriously individually model the bypass capacitors for each chip, which is going to vary for each different chip? For each chip has its own unique bypass requirements, right?
Sure.
Especially based on layout and functionality.
Yeah,
and
well, and like switching
all
speeds
sorts
and
of
stuff like
Yeah,
that. If you
all
have
sorts
like
of stuff.
Yeah.
Right? Yeah. It depends where, if it's an FPGA that draws massive gulps of current when it first powers on, you might need a lot of bulk capacitance. If it's some, high frequency thing, you're going to need some lower values to have lower ESR at higher frequencies and stuff, like more effective or whatever. You might need different types of bypass capacitors. You might need it's just endless. So you can't possibly model each one. So there's a reason why.
No, you could. Just most people won't. The cost of doing so is
if you're sending a probe to Pluto, you might do that.
Right. Well, or if you're making a front end for like if you're going to make something that Shariar is going to pull apart at some point, you're probably modeling everything.
If it's some 100 gigahertz thing, yeah, of course you're going to start modeling your stuff, right?
Yeah.
But your average,
if you're making something that's like 10 megahertz and below, yeah, you're probably cool,
And that's the thing. So they're lamenting the fact that nobody does modeling of their bypass capacitors. Well, it's bloody not easy. You can't just like you could spend weeks just modeling one bypass capacitor and measuring it properly. Seriously, you could spend weeks just doing that one thing for that one chip.
So I got a really good education on all this stuff from Mr. Mighty Ohm. He was helping me when I was starting to learn RF stuff, and like he was really, really doing a good job. Well, my learning was very slow, but like he was very adamant. And this is Jeff Kaiser, if people don't know who Mighty Ohm is.
Yeah.
Past guest of the show and past co-host of the show. But he always tries to like talk about how important it is that like capacitors and inductors have like all these other characteristics like you're talking about.
Mm-hmm.
But I think the thing is, I wasn't up until the point where I was starting to dip a toe into the RF world, like it mattered. Of course it mattered. And it probably had like failures. I probably had like intermittent type of problems in circuits that I designed poorly as a younger engineer kind of thing that maybe I just didn't catch, or that, it surely matters.
Yeah.
But it really starts to matter at a certain point, especially when, like, if you got Eric Boken talking about it and it has signal integrity somewhere in the title, it's like, oh, okay, you're probably up at higher speeds. You're really needing to worry about all of that. What seems like corner case stuff becomes a much, much bigger piece of the pie. And so if I was going to go back and tell 6 months ago, Chris, I'd say, first off, invest in masks. You can help people.
Yep.
But after that, or sell all your stocks. That'd be the other thing. But after that, I'd be like, understanding like how all of these other things, like Jeff was talking about, it's important, but it's only important when, not only important, it's increasingly important as your speeds move up in time, and don't stress about it too much until you really are moving up in speeds. And I think that threshold, you could say it's 100 megahertz, you could say it's a gigahertz, it's somewhere in there, right? It's maybe even lower than that. But like, if I went back and told 20 years ago, Chris, I'd say buy some stocks, and then I also say maybe don't worry about this stuff so much. Like.
No, yeah, of course, right. And well, see, the thing is, right, you go to the experts at Xilinx and Altera and those sort of companies, right? Who, like, if you've ever seen, there's probably no more bypassing on any chip in existence than an FPGA, than a modern high density FPGA, right?
Yeah,
if you look, right, and they
I'd say maybe like an Intel processors underneath. Like they've started to put them in the packaging too.
Yeah, of course. So. Oh, yeah, no, it's all high-end processors, right? FPGAs are high-end processors and things. They have like 100-page application notes dedicated to power supplies and bypassing of their chips. That's how important and complicated it is, right? And even in there, they just go, oh, use a 10 mic, use a 1 mic, use 100N, right? So... It's because it is so ridiculously complex to actually test and model this sort of bypass stuff. Yes, you can do it as an academic thing, or if you have very specific requirements to do it. But even the experts tell you, just whack a 10, even like Xilinx, right? You're whacking 100 mic because they have, as I said, those huge gulps of current when you first power them on. Right, massive gulps of current because all the SRAMs have to be set up or whatever, and then you've got like a 1 mic and then 100 and then a 10N, and so that's why. And then they've got 20 power pins on the chip, right? So then you end up with 100 bypass capacitors under a modern high end FPGA, right? It's crazy, but that's the recommendation from the experts, right? So, but then you've got experts on top of experts like Eric Bogerton, right, who take their...
Well, and he is an expert, yeah, of course.
Of course, right? And
he does he do the rules of thumb? Is that his category? I thought he does those. Yeah, he does rules of thumb.
Yeah, so those guys who spend all their their hobby is actually getting out their VNA and measuring the measuring the impedance of bypass caps under various scenarios, and they design different boards and how much impact a VIA has, and and which is great. It's fantastic academic research that has lots of practical implementations. But unfortunately, at the end of the day, engineering is about getting a job done on time, under budget, and with a good enough margin, a good enough design margin, that you've often got no choice but to just whack, 2 or 3 bypass caps in parallel and cross your fingers.
Yeah, just get it out the door.
Yeah. But then, like, there's lots of traps. As I mentioned in my videos, traps for lone plays. The more, actually, technically, the more caps you put in parallel, the more chance you have of actually hitting some obscure bypass resonance. And especially if you've got if you're trying to bypass like a phase lock loop chip or something like that, if you have the right combination of bypass capacitance, tracking impedance, track inductance, and things like that, you can actually cause more problems. You're better off with no bypass capacitor than putting a bypass capacitor of the wrong value on there.
Oh, really?
Because it can hit a resonance, and LC resonance. Oh, I have to find it. I don't know. I've done a couple. done a couple of videos on this. So, yeah, I'll share the link after the show, and I will give you. Yeah, but it's a real thing because you've got a capacitor, you've got an inductor, which is all your traces and your ground planes and everything else, right? Hello, LC resonance, like that's actually a thing, right? So especially, and the other thing is if you're trying to bypass like fast rising edges, of course, right? Everything's switching like that. Eventually, right? If you've got an infinitely fast edge, then you have an infinite number of frequencies effectively that you're generating.
Fourier says as much.
Yes,
yeah.
Fourier, right? Fourier says this, right? It's a real thing. And yeah, so the odds of you actually finding one of those resonant peaks that matches up with your bypass capacitance and your trace inductance, ooh, you can really come a gutser, and that can really cause big overshoots and things like that. It can resonate slightly and actually cause more overshoot and undershoot than you're trying to actually, than your bypass capacitors are trying to minimize, right? Because the whole idea is you're trying to stop ringing on fast changing signals, right? With bypass caps, right? You're trying to keep everything nice and tight. But yeah, you get it wrong, and it can be a real problem. So, but thankfully, it's pretty obscure, but it does happen. Just be aware of that. So,
yeah, yep.
So yes, big, complicated, messy subject, the myth of the three capacitor values. So you have your purists like Eric who's saying, you don't know what you're doing if you're just whacking all three in parallel. And he certainly has a point. On the flip side, that's often the only way you can get engineering done, you know.
Yeah.
So
well, he is the one who does the rules of thumb, and I like that article series. I'll link that, but I guess this would not be one of them.
Right.
This is like a rule of thumb what not to do, you know.
But the thing is, today, he shows like an impedance curve, of course. If you just put like a single 10 microfarad bypass cap, right, that is more effective over a wider frequency range than a single 0.1 microfarad. And that's great, right? Saying that is fantastic. Well, why don't you whack in 100 mic? Well, size, cost, right? Actual capacitance, which varies, once if you want an 0603 100 mic capacitor, you can buy it, but it's not much of a capacitor, right? Its dielectric is awful. It's one of those awful dielectrics which changes with voltage, and it's just, right? Terrible Y5U dielectric, right? Awful, hideous stuff, right? It's not X7R. Right.
That's right.
It's hideous. And they're expensive. Like you can't afford to populate your board with, 10 microfarad caps everywhere. Geez, that's actually going to add up. If you've got a big board and you've got 100 10 microfarad 0603 ceramic caps on there, that's a big cost. So, yeah. So, yeah. There's no magic bullet there, I'm afraid. Engineering. It's wonderful. Trade-off. So, yeah. Anyway, go and read the article. It's fascinating.
Yeah.
Yeah.
Okay, so I'm gonna pull a. So I had asked on the Discord earlier today about what people wanted us to talk about. Here are some potential topics that were recommended. Trade-offs between simulation versus experimenting, which I think we kind of just covered there, which is kind of interesting. Another one was staying motivated when you don't have people around. I think we kind of talked about that earlier. So these are all kind of good. Lance asked about comparing SPICE programs. I was trying to think if we've talked about SPICE in the past. Have we talked about SPICE?
Oh, various times over the years. I mean, what's a name is free. They've just released Microcap. You remember Microcap, right? It dates back. No, you haven't. No, you haven't used it. Anyway, it's a famous circuit simulation package that dates back to the 80s or something. I used to use it in the early 90s probably. I used Microcap 3, I think. Now it's up to Microcap 12. Anyway, the designer of that, it's written by one guy. So I forget his name, sorry. But he's finally retired and said, I don't want to do this anymore. Here, it's free. So he's released Microcap 12. It's completely free. It used to be like a paid package. He used to sell like a pro version. Now he's just giving it away for free. And you can get it's pretty good, Microcap. Once again, pros and cons for each package. Some people swear by it. Other people go, oh, no, I don't like it.
Mm.
it's one of those things. Some people like LT Spice, others hate it. It's yeah, yep. So anyway, so that's free. There's a big forum topic on the EV blog forum about that, and free. And I was probably going to try and maybe get in contact with him and see if he wants to come on the show or something like that.
Oh,
So,
yeah, that'd be great. Yeah.
talking about simulators and whatnot. But anyway, there's lots of free simulators these days, so which is really good. So choose your, and there's even web-based ones are pretty good. There's these
Yeah, I mean, they're all using
fancy
like
web-based ones.
the open source engines that are out there, like the Berkeley engines.
Well,
and
they're
stuff
all
like that.
using the Spice engine, right?
Yeah, exactly.
It all comes
it's like a
from
web
the
front
original
end for a engine. Yeah.
Yeah, I believe almost every one of them. Please correct me if I'm wrong. Almost every one of
You're
them
wrong.
comes has.
You're
I'm
wrong.
wrong. Comes from the Berkeley Spice engine.
No, it's
Almost-
because Mike talked about it when he was on the show. So Mike Engelhart was on the show. We'll link that in. But he talked about how LT Spice was not the Berkeley because he had all these criticisms about it, and I had no idea what he was talking about.
I thought he used some of it.
I think it's all based on it, but it's not. I remember him saying specifically
That's what
it's
I'm
not
saying. Yeah. That's what I'm saying.
Okay, sure.
It started from
the
based on
Berkeley.
some of the. It started from every simulator is almost.
But I think
has some.
But I think that some of the web ones that are out there
Berkeley
are actually still using the Berkeley engine underneath.
Right. Okay.
Whereas some of the other stuff has diverged and taken other.
Oh, of course.
I don't know.
Yeah. No, if you work on it long enough, of course,
tree.
it's going to eventually evolve into something that's not.
Right. But I'm just saying that some of the cheapo web engines, it's like a nice web front end, unlike something that's just open source and kind of out there, and so they didn't really think as much about the stuff underneath. But for what a lot of people need, it's kind of like the same thing with the capacitors. It's like for people that are just getting started and need to just want to have a visualization or something like that. I think
of course,
it's fine.
Yeah. Oh, there's tons of them out there now. It's great.
Oh yeah. And I think the ones that actually do have nice visualizations are like Falstad does that. The Falstad circuit simulator thing. And there was another one that was out there that was like that too. I really liked how it visualized AC waveforms and stuff like that. Talking about capacitors again, seeing how things like that kind of getting a mental model for that is just so important. So
it'd be nice to do a shootout video or something like that, but unfortunately, everyone's requirements are different.
Yeah, exactly.
It's you can't say which one's best. It's this one might have nice, visuals and things like that. It shows the current flow and with these nice animated colors and everything else, and fantastic. But for other people, that's useless. So. Is there a list? I'm sure there should be a big list of simulators out there. Yeah, someone's done it. Guarantee it.
Other questions from the I kept wanting to say subreddit, but it's actually the chat. I don't know what it's from the Discord is listing of hobbies that are electronics adjacent that are not just building electronics.
What do you mean? Yeah, examples. Yeah.
So examples given were like RC planes, or
right.
RC is a hobby.
Yeah.
You're working on electronics, but the end goal is to usually to build a thing instead of just building a circuit. Or ham radio, it's usually to communicate with someone over vast distances, but you have to have electronics in there. I wasn't sure of the other ones. Maybe
there's countless examples.
Yeah,
I'm sure.
Do you have any offhand?
Oh, anything in life can be.
Dave, you're on the spot.
Anything that involves electronics and stuff like that. You could.
Yeah, I don't know. It's been kind of it's come up again with thinking about the ventilator thing and in terms of, it's much more a systems problem, right? There are electronics in a lot of these things. Some of the solutions I've seen out there,
music, for example, music. A lot of people, might design their own effects pedal or something like that. They might design their own audio amp because they the sound of tubes. So they'll design their own tube amp.
Yeah, that's a good example.
Yeah.
Okay.
And there's other ones where you'll design a little gadget to help out or something like that. You might be into astronomy, for example, but you need a custom motorized drive for your telescope.
Yeah.
Just as a random example. So you build like a little custom motorized drive and mount and things like that. So you've got to, got to design circuits. You've got to maybe 3D print all sorts of stuff. You might have to machine stuff. You might have to do all sorts of things. You might have to. I guarantee there's a million examples. If we ask people
Yeah. I mean, sure there are, but
yeah,
I don't know.
We're just too dumb to think of them, right? Yeah.
I was just asking for questions on the Discords. I just asked questions. I didn't have to think about answers. That was for us to discuss here.
So the OP wanted other examples, did he?
Yeah, exactly. Yeah.
Right.
Exactly.
Okay.
And there were some other examples in there. I didn't want to give them away though. Come on, I've got the answer key in front of me, Dave.
All right.
Like home automation was also in there. 3D
Oh,
printing
yeah, of
was an
course.
example.
Yeah.
Although 3D printing is kind of like a fundamental type of thing as well, right? So like the goal might be to make figurines, and 3D printing is like a enabler of that that hobby.
Of that. But there's like all the people are into fashion these days. Everyone wants their their dress to light up, right? So they've got to
like
make a custom thing, or the wearables stuff,
Yeah.
So people that are into who would think have no association with our world at all are now using little.
And Lord knows that we don't have any association with anything that's fashionable. So no one has ever accused me of having a good fashion sense. That's for sure.
Right.
Maybe someday. Maybe someday when I combine my knowledge of electronics with clothing.
You'll make it big, huh?
No, I won't.
No. All right. All right.
There was one other thing on the list. What was it? So someone had written in from a large company, and they heard John Day, who was on the show. He was from Microchip. And so an engineer in another company was inspired by that and wanted to know, was basically asking for other app notes that would be useful to listeners of the Amp Hour audience. I mean, yeah, it's like a super broad thing, right?
Super broad. I mean, app notes. Oh God, there's just. I've got one. I've literally got one open in front of me right now, which is the TI AN11. This is app note of the week.
Sure.
This is the Texas Instruments AN1148 linear regulators, theory of operation and compensation of linear regulators. So if you want to know about your pole,
what's the number again?
It is AN11-1148.
1148. So that shows there are a lot out there.
Yeah, and this goes into your poles and your zeros and your phase margins and your bode plots and your different types of LDO regulators and your phase shifts and all your sort of stuff about if you want to design your own power supply, for example, all sorts of stuff to do with like stabilizing the loop, stabilizing your power supply and all that sort of jazz.
Right,
op amp compensation and things like that. So, yep. And that's, how many pages long? I don't know. Actually, this one's not that long. It's short. So it's easy bedtime reading.
Okay.
But sorry, it's not an application note. It's an application report. So maybe,
okay.
I don't know why I have this. I had it open for some reason. I've got lots of tabs. I'm a tab, hoarder.
Yeah. Right.
Yep. And I had it open for some reason, and maybe I was stealing an image from it or something for a video, as I often do. So so it's not it's not the most comprehensive one out there, but it might give you a nice overview of how phase margin works in power supply design, for example. So there you go.
Yeah, I mean that's the thing. Like there are so many narrow topics that you could ask someone to do, but this was an offer from someone at a large chip company, like no strings attached. They wanted to know some. So if you got suggestions, we'll link there. There's a subreddit, and I'm just going to send the subreddit back to this person when they're.
I'm surprised you have not mentioned the ultimate, which is the Keithley low power guidebook.
Oh, the low level management, low level measurement handbook.
Low level measurement handbook. That's it. It's like the Bible in the industry of low level
edition.
Measurement.
That's what they were on when I was there. It was the sixth edition. It might be up to 7th now.
Is there actually a printed version of that?
I have one. Yeah.
Oh, you did. Okay. All right.
Yeah.
There you go.
Yeah, it's good. It's short and it's
short.
It's probably.
It's hundreds of pages, isn't it?
No, it's only like
the Keithley low measurement handbook. No.
Let me double check. It's on 7th edition now, and it's by Tektronix, not Keithley, of course. Yeah, let's see. It's wow. Okay, never mind. It's 244 pages.
Thank you very much. 7th edition. Yep.
Maybe the printed book was like
Right.
They're like, yeah, just take this. It's like the first chapter.
Right. Yep. Here I am. It's still Keithley branded. Keithley, a Tektronix company.
Well, on Google,
yeah,
it's not. That's what it. Yeah.
Oh well, the one I just downloaded, the 7th edition, and it's got big Tektronix in there, but it's also got Keithley. Low measurement handbook. Yep, it's a couple hundred pages long. So, yeah,
it's a good one.
beast.
That's a good one.
Yep. It's
that was a good investment in education on their part for sure. Yeah, and it was kind of like there's lots of app notes that are out there. App notes and also like white papers, sometimes. But it's usually you can tell pretty quickly how high quality the content is.
Oh yeah.
So
yep.
people who listened to the episode with John Day, you could tell like there was some time that went into the stuff he was working on, and like that kind of thing.
There's one I keep going back to because I just did another recent video on how to convert an LCD into an e-paper display.
Oh, cool.
And I keep going back to the microchip app note of how LCDs work. I can't remember the exact. If you search a microchip LCD app notes, it'll probably pop up. It's AN658. AN658. That's the second app note of the week. And it's from Microchip. And it's, And
if you wanted to do this, we could just be like AN658, app note of the week. AN657. App note of the week.
Yeah. And it's great. It's just like how LCDs work, how to drive them. It's got fantastic diagrams in it, which I stole, of course, because they're fantastic, and put them in my videos. And it's just it's really great. So if you're driving LCDs, if you've got a product, this is the app note that you want. So someone's put a lot of work into that. Mary Tamar Tan. Roger, Ricky, Jason Layton from Microchip Technology. There you go. Three authors. Fantastic. Yep. Yeah. It's a great app note. So, yeah, there are some classics like that. It actually dates back to 1997 by the looks of it. Wow. And it's been updated, but yeah, it's just an absolute classic. It's just got tons of stuff in it. It's terrific.
This app note could have a beer at this point.
Yep. Love app notes.
All right. Well, we should cut it off here. But as people may have noticed, we have a Discord now, and that is brought to you by, and this show is brought to you by, in part by our patrons who we are very grateful to. So thank you to them. If you want to join in, it's as little as $1 per month, and so you can do that.
It's not it's per episode, isn't it?
We do per episode, but you can if you only want to do $1, you can do $1. It's $1. You basically say, hey, I want to do $1 per episode. That's the minimum you can do. And then you say the max I want to do per month is $1. And so basically you only get charged for the first episode of the month. So,
I didn't know Patreon had that capability. I thought you had to choose either per episode or per month.
Well, we do as the creators, but as people like sponsoring, so like they sponsor an episode.
Oh, I sponsor an episode. Okay,
so they say like I will pay $1 per episode, but I want to cap it at some. So if we put out like 100 episodes in a month, they might say, well, I only want to sponsor the first up to $10 worth, right? So it's like a cost prevention for them.
Yep. Yes. Yeah, because that is the risk if you back somebody on Patreon and then they spew out 100 videos in a month.
Yeah, exactly.
Then you can get charged a lot of money,
Exactly.
So, yeah.
So, anyways, as little as $1 a month to be part of the community and support the Empire. So we appreciate everyone who does.
Awesome. Thank you very much. That's it.
All right, man.
We're well over.
Stay safe, stay healthy, wash your hands. We'll talk to you soon.
Catch you next time.